Yeah, you can see. Mm. Uh, I want to redraw the circuit and explain how we're going to get the uh
Total current.
yeah the final current. My Zoom wanted me to upgrade it, so that's why shut it down. So it's 2 amperes, yeah. 8, 12, 20. So the circuit is like this, and we have currents. I will remind me the currents. The IRL one was 0.4 ne? Amperes.
Yeah.
IRL2 is equals to 0.
0.533.
Then IRL3
0.66.
0.066 or
0.36.
0.36.
0.366.
0.366, okay. Amperes, yeah. So IRL1 is for 9 volts, then IRL2 is for 3 amperes, then the last one is for 2 amperes. So now we want to determine what happens.
Predictions.
So now we want to determine the total resistance for RL. I mean the final what? Our final current for the I for the
Yes,
root
over
resistance.
RL.
Yes. Mm. We want to determine the final current for our 12 ohm, which is our RL. So question is how going to determine the current through 12 ohm? We're gonna use the directions of our voltages and the currents. So the direction of this voltage,
Yeah.
direction of 9 volts to what? To RL. We use the direction to RL. So we point them to what? To our load. So
Yeah.
the direction from 9 volts, move it up again. Okay, yeah. So the direction from 9 volts is going up. The 9 volts is going up. All the direction of our sources, they are going up, ne? They are all going up. So for 9 volts, it will start and then go to our RL, and then for the 3 ohm to our RL. So the 9 and 3 amperes, the current that we got from the 9 and the 3 amperes, they are going
The
towards
same direction.
from the left to right. So the one for 2 ohm is from right to left. So you can see these two and opposite to the one. So the final current for IRL is going to be what? Is going to be 0.400 plus 0.53
5,
minus
0.66.
0.366. Yes. So that will be the final current for IRL.
is 0.499.
It's 0
So
point
I guess 499.
0.499. Now I'm getting 0.57. Oh,
Kan het?
yeah.
Oh, hey, die hele Porsche.
Is
Yeah,
what?
I guess 0.567.
So the final current is 0.567
7.
amperes. Then that's how we use a superposition to calculate the current. That's how we apply superposition.
Right?
Ne?
Eh,
Yeah, that's how we apply superposition to find the current. So what you need to be good is circuit analysis. If you understand circuit analysis, then superposition is going to be simple for you because normally we're applying circuit analysis to get the current mm, through the resistors. Ne?
all
So
right, yeah, yeah.
now we can prove our answer. We can prove our answer using what? Using a Thevenin and Norton. You are aware of Thevenin and Norton.
Yes, I am.
So let's prove our answer using Thevenin and Norton. Both laws they must give you same answer. Ne?
Eh,
At the end, both laws they must give you same answer. Uh, I want to charge the PC. Is the PC. Mm. Okay, so now let's apply the Thevenin and Norton to get the current through our 12 ohm. Let's apply the Thevenin and Norton. Ne? So I'm going to add another page. Let's go to the new page. Okay. Oh, sorry, it's a voltage source. The circuit diagram. 6 ohm, 2 amperes, mm, uh, is 8 ohm, 8 ohm there, 20 ohm, 12 ohm, 3 amperes, 4 ohm, and 9 volts. So applying Thevenin and Norton,
Yes.
Thevenin and Norton, uh, when applying Thevenin and Norton, we call it a source transformation. We call that law a source transformation because we're applying both laws at the same time. So we call that a source transformation. So to get the current through the 12 ohm, we're going to apply a source transformation and then circuit reduction. Circuit reduction, I mean, at the end, you must be left with voltage, one voltage source, and then and two resistors at the end. So now I'm applying a source transformation, which is Thevenin and Norton. So always I'm going to start from left, né? Or I can start from 6 ohm. You can start anywhere. Since it's a Thevenin and Norton, you can start anywhere. But let's start from the left. So what are we going to do here? We want to get a we want to summarize or find one resistance which is going to be our R Thevenin or R Norton. Our load resistor, we're going to eliminate it and just put the arrow for a reminder we have a resistor there. So normally at the end you must have two resistors and then voltage source. I mean a source. It can be voltage source or a current source. So now what I'm going to do, I'm going to start from my left side. So I'll transform this to what? To a current source. You can transform a voltage source to a current source to a voltage source. So if you have a voltage source, it forces us to transform it to what? To a current source. If you have a current source, it's going to force you to transform it to a voltage source. So I'll start transforming this. I will have something like this. So always when you transform a voltage source to a current source, connect that resistor again in parallel. When you transform a current source to a voltage source, connect that resistor again series.
Yes.
So now let's go. We'll have what? 9 divided by 4 is a current source, ne?
Yeah.
9 divided by 4 going to be our current source. Then I will bring that 4 ohm down. Our current source over there. Then we put an arrow for the load. We put an arrow to show that there's a load there. And then 8 ohm. And there's also the 20 ohm there. Okay.
Oh, yeah.
6 ohm, 2 amperes, 8 ohm, 20 ohm, mm, 4 ohm, and then this is going to be the 3 amperes. Something like this. You understand this part, ne?
Yes, I understand that part.
This was transformed. I've transformed this into a current source. So when you transform current source, now the resistor, you connect it in parallel. So I want to rearrange current source and my resistors from this. Then the circuit will look like this. Mm, Mm. Then that will be my 20 ohm, 4 ohm, 3 amperes.
9/4.
So it's gonna be like this. You agree with me?
Yes, I agree with you.
Okay, then since these two currents they are pointing in the same direction, well, what are we going to do? We're going to add them. We're going to add them. So I can say I call it IN
Can't
because
we add it with that other one?
hmm?
Yeah, can't we add it with that other one, the two amps as well?
No, because of this. Because there's a
Oh,
resistor here and it's in
all
series.
right.
I can't take this from that side. I can only take if it was parallel.
All right. Yeah.
So I will add these two. I will add uh, since it's currents, I'll call them Norton. I'll call it IN.
About 5.25.
Is what?
5.25.
5.25.
Yeah.
0 or
Now 5.25.
okay. Amps. Then
Yes.
I have look at this. They are parallel, eh? These two resistors.
Yeah.
And I'm applying circuit reduction. So I have to replace them with one resist.
Becomes 3.33.
So it's RP1 equals to 4 times 20 divided by 4 plus 4 plus 20 is equals to
3.33.
3. And then 6 and 8, they are parallel as well. Ne?
Yes.
Then RP2 is equals to what?
3.428.
9.
Let me check.
3.429.
A.
Okay. Okay. Then I can redraw the circuit now. And let's see how it's going to look like. Mm, so,
Not increase one.
hmm? So is 5.25 ne? Amps. So now I have something like this. Now I'm applying Thevenin and Norton, and my load resistance is in the middle and is connected in is incorrect is connected in connected horizontally. Ne? So
Yeah.
remember my R load is here. So since it's like this and my arrow is like this, so I can't add these two currents and I can't say these two they are parallel. Ne?
Yes.
I
To
can't say this.
separate given
So
the
that
load
means
resistance.
so that means I have to convert this to what? To a voltage sources. Ne?
All right.
I have to convert this to a voltage sources. So converting these to voltage sources, I will have voltage source one is equals to 5.25 times 3.33 is what?
17.483 volts.
Okay. Then V2 is equals to 3.429 times 2
3.429
times 2 is what?
6.858.
So I'll write it here. V2 is equals to
0.858.
6.858 volts. So that will be source transformation of V2 and V1, whereby I transform these two currents. So I don't have space. I want to erase. I will erase the final circuit and I want to draw the. I will erase the original circuit. And then, okay. So the final circuit, the next circuit from this, from transformation these two currents, I will have something like this. I will have something like this, 6.858 volts there, and then 17.483 there, and 3.33 ohm there, and uh, uh, 3.33 there, and 3.429 there. So now I have something like this. Net.
Yes.
So from here I can do what I can add because I can see they are in series. So from there I can add the two resistors because you can see they're in series. Let me create space here. Okay, okay. So from there, if I add these two they're in series, so what will happen with these two voltage sources?
What will you want?
What will happen with these two voltage sources?
Will you not add them as well?
No, we don't add them because they are facing each other. We subtract. Ne?
Oh, all right. They're in opposite directions.
Yeah, they're in opposite direction, so we subtract.
Mhm.
Yes. So what will be the resistance?
6.762.
Is 6.7 uh 6.762. I bring
And
back the
then
what? My R
the
load,
12.
ne? Yes.
Yeah.
17.483 minus 6.858. It's going to give us what?
10.625.
10.625 volts, ne?
Mm.
So that will be our RL, and this one is going to give us R Thevenin. It's going to be R Thevenin. So now that's the final circuit. Always, when you're applying Thevenin and Norton, you always will be left with, at the end, you must be left with a Thevenin circuit or Norton circuit. Ne?
Yes.
You know, Norton circuit, we want a current. What is a Norton circuit? Can see it by the current source. And then
Yes.
that will be,
And then
yeah. So now let's find the current through 12 ohm through our load. IL is equals to 10 divided by 6.762 plus 12. So answer divided by 12 plus 6. It's giving me 5.6
0.567. 67.
6.7.
Eh,
6.7. So we got this using what? The Newton and Thevenin, ne?
Yes.
This is what we get when applying Newton and Thevenin. So we first applied superposition. Always the laws at the end they will give you the same answer. So let's confirm it. Are they correct? Are they the same?
Yes, they're the same.
Yes,
Yeah.
they are the same. Here we applied superposition. The current is 0.567, and then
Gave
now
us,
here we
yeah.
applied Newton and Thevenin.
So 0.567.
The current is still the same. So that's how we apply Newton and Thevenin as well as superposition.
What's up, because that last thing ne a ka mo kwešiša gabotse ga explainer this Norton and Thevenin gabotse be impalela le gale le gale.
Mm.
So I watched these YouTube videos, and then the way they're doing them from
Different.
the way you are doing it, and yeah, it's different. But now they don't do source conversion and things like that.
Mm.
They remove the sources, calculate the RTH or the RN from there, and then afterwards they will apply either superposition or whatever law to get
To get the
IL or VTH. If
mm.
I do that, because that's the method that I understand a bit more, will I still get the marks?
Applying superposition or another
No,
law.
like doing Norton and Thevenin
Mm.
Mara without source transformation.
Mm.
I might not get the marks, ne?
Yeah, normally we have to do what we just applied. The one of transforming the current source to voltage source to a current source.
All right, mara ke nagana ka mokgwa o e dirileng ke a e kwešiša ke tla ba sharp. Yeah.
Yeah, that's how we do it. That's how we do it.
I but that's how the lecturer did it.
Mm.
What are you being confused?
Mm.
This thing of when you after you add these parallel circuits, now it's series and but now I noticed the pattern like when you were doing them or okay, if you added them in parallel, the next one is going to be in series with that one, and then the
Yeah.
next one is going to be parallel. So
Yes.
big say no to you, but now I understand it.
Okay. Yeah. So yeah, e gona ka mokgwa.
Right.
Mm.
Maybe we can do example yeah Norton and then or whenever
Norton, they won't ask you to apply
Mara it's the same.
Norton only. They will always
Or
ask
they
you to apply Norton and Thevenin.
yeah, Mara get Thevenin we did like a example in so you're not given
Mm. Thevenin Norton,
or
we,
una
yeah, we can always apply Thevenin Norton.
yeah.
Yeah, I mean, if they give you a second, they say apply
Oh,
Thevenin
all
or
right,
apply Norton. Apply both. Apply both. Ne?
all right.
Because it's easy when you're applying Thevenin Norton, but when applying Thevenin
Okay,
only or Norton only, it becomes difficult.
all right. Yeah, Kushi.
Yeah. So I don't know. Ke sene kwa busy ka something a ke tse bore e nngwe re ka fele janeng ka mabano go ba ka fele ka moswana after writing the programming test.
Yeah,
Ne? Ngushisha?
eh, big sa go kwe. I think it's best that I continue
Okay.
after the test.
Okay. Sure.
Yeah, Lebura, thank you.
Chap chap.
Sharp.